In this video, we're going to talk about how we determine if a pair of functions are inverses of each other. So on a problem like this, you would definitely need to show your work because you have to prove to me that when we do the two function composition, so when you compose f of g of x, that it equals x, and then when you compose g of f of x, that it also equals x. If you get one or the other of them not to equal x, then they're not inverses of each other. So let's start with the first one here. I'm going to go f of g of x. So I'm going to start by writing my outer function f with parentheses for the x. And then I'm going to take my g function and I'm going to substitute it into the parentheses. Now I'm going to evaluate that. So I know that the fourth root and the fourth power are basically going to cancel. So I'd be left with 3 times x over 3. Then my 3's would cancel, and that is going to give me x. So this side checked out. It was equal to x. Let's look at going the other direction. So add g of f of x. All right, so my outer function is the g. So we're going to go fourth root. I could write parentheses if I wanted to, of x over 3. Now I'm going to take my f and just put it into those parentheses. So 3x to the fourth. It does look like my 3's are going to cancel. So we've got the fourth root of x to the fourth. And then the fourth root of x to the fourth would just be x. So it looks like this works. So this pair are inverses. All right, let's look at this second pair here. I'm going to start with f of g of x. Okay, so I'm going to write my outer function f. Instead of writing the x, I am going to write parentheses. Then I'm going to substitute this into the parentheses. So cubed root of x minus 2. There really isn't any way, even if I dropped these parentheses, there's no way to combine anything together. This part here means, hey, write that 3 times. So if I were to multiply this out 3 times by itself, no matter what I do with that, it's not going to cancel to x. So this one would be that they're not inverses. No, not inverses.